Today we're going to be summing discrete data sets. We're using summation notation. A series is the sum of the terms of a sequence. The sum of the set of numbers is a finite series. So we'll be working with finite series. A sigma or summation notations of a series. So this symbol here is called sigma. You have your index, you have the lower limit, and you have the upper limit. The index can be used as many different letters. It can be an I, a K, an N, whatever letter we want. The lower limit tells you where you're starting, and the upper limit tells you where you're ending. As it's written here, you would read it as the sum of a to the I from I equals 1 to n. Normally there'll be numbers. So normally you'd say from 1 to 5, or whatever that number is. What a summation is telling you to do is to add each term of the sequence from the first term, index term, the lower limit, to the upper limit. So we'll add the first one plus one more all the way down. Some examples will make it pretty clear. Here we have the summation of 3n plus 2 from n equals 0 to 5. What we're going to do is find the first 6 terms starting at n equals 0. All you have to do is substitute in it, just like we did before. 3, 0 plus 2 is equal to 2. 3 times 1 plus 2 is equal to 5. 3 times 2 plus 2 is equal to 8. 3 plus 2 is equal to 11. 3, 4 plus 2 is equal to 14. 5 plus 2 is equal to 17. Some of you probably noticed this is simply an arithmetic series, and we're simply adding 3 to each term after the first term. So if you didn't want to write all these out, those of you who realize this is an arithmetic sequence simply could have said 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17. Now the big difference between the arithmetic series and what we're doing now is a summation adds all the terms. So there's an addition between each set. Then all you do is go through and add them. 2 plus 5 is 7, plus 8 is 15, plus 11 is 26, plus 14 is 40, plus 17 is 57. So my answer would be 57. The summation of 3n plus 2 from n equals 0 to 5 is equal to 57. Now they won't always use n, they won't always start at 0, and they won't always be arithmetic. Here we have another one that uses k, and it starts at 3. So we would say the summation of k squared minus 2 from k equals 3 to 5. Then just do the math. 3 squared minus 2 is 9 minus 2 equals 7. 4 squared minus 2 gives us 16 minus 2 is 14. And then 5 squared minus 2 is equal to 23. This is a summation, so we need to add them. 7 plus 14 plus 23 is equal to 21 plus 23 is 44. Moving on to your favorite things, fractions. We have the summation of 1 over n from n equals 2 to 4. 1 over 2 plus 1 over 3 plus 1 over 4. Now we need a common denominator. The easiest denominator out of all these will be 12. I multiply this by 6, multiply this by 4, and I multiply that by 3. That gives me a common denominator of 12. 6 plus 4 plus 3 is equal to 13 over 12. Remember, whenever you have a fraction, always see if you can reduce. This is not reducible, so we are finished. Here's another one that starts at 0. Walk through it. 5 times 2 raised to the power of 0. Remember, any number raised to the power of 0 is just 1. So 5 times 1 is 5. 5, 2 to the power of 1 is equal to 10. 5 times 2 to the power of 2 is equal to 20. And then 5 times 2 to the power of 3 is equal to 40. Now some of you saw, because we have a 2 increase in the exponent, we're just going to keep doubling. If you didn't see that, that's fine. If you did see it, you can shortcut your way through this. Either way, you add them up. 5 plus 10 plus 20 plus 40 gives you 15 plus 20 is 35 plus 40 is 75. Your answer is 75. So really these are pretty easy. All right, here's another one. Looks difficult, but again, these are pretty easy, not that difficult, just substitute them in. N minus 4 means n is equal to 1. 1 minus 4 times 1 plus 5. That gives you negative 3 times 6, which is equal to negative 18. Then do it again. 2 minus 4 times 2 plus 5. Notice every time I have an n, I'm simply increasing the number. That gives me negative 2 times 7, which gives me negative 14. Again, 3 minus 4 times 3 plus 5. Negative 1 times 8 is equal to negative 8. And one more time, 4 minus 4 times 4 plus 5. That gives me 0 times 9, which is equal to 0. Now I add up all the numbers. Negative 18 minus 14 minus 8 minus or plus 0. It's a 0, doesn't have minus or plus. Negative 18 and 14 gives me a negative 32. Negative 32 minus 8 gives me a negative 40. So my answer is negative 40. Now these were pretty quick and easy. What if they're given to us backwards, meaning we need to create the summation? And that's where we are here. Write each of the following sums in summation notation. Now, this is very similar to what we were doing last time, where we had to find the geometric or the arithmetic sequences. That's how we start. We look for those sequences. So the first thing we do is subtract. 8 take away 5 is 3. 11 take away 8, 3. 14 take away 11, 3. I have a common difference. So now we set up my arithmetic sequence. Remember, your arithmetic sequence is your first term plus n minus 1 times your difference, your common difference. Here, my first term is 5. So I'm going to say 5 plus n minus 1 times our common difference is 3. Now for these problems, they want you to simplify. Most of the questions will even tell you, write it in simplest form. So I need to simplify this. 5 plus, I'm going to distribute the 3 through, gives me 3n minus 3. 5 take away 3 is 2. It gives me 3n minus 2. So you write your sigma. Then you say where we started. Well, we're using the letter n, not I, so I say n equals. The first term, we start counting with 1. And how many terms are there? 1, 2, 3, 4, 5, 6, 7 terms. We started at the first term and we went for 7 terms. Of what? 3n minus 2. This is our answer, creating a summation. Do it again. We look for a common difference. 6 take away 3 is 3. 12 take away 6 is not 3. Don't care what it is, it's not 3. So common difference didn't work. We look for a common ratio. I divide. 6 divided by 3 is equal to 2. 12 divided by 6 is equal to 2. One more time. 24 divided by 12 is equal to 2. So I have a common ratio. That means it's a geometric sequence. If it's a geometric sequence, we use the form a1 r n minus 1. Here, our first term is 3. Our common ratio is 2. So we'd say the summation from n equals 1 for how many terms? 1 term, 2, 3, 4, 5, 6 terms. Our common ratio was 2. Our first term is 3. So you would say 3, 2, n minus 1. Now here's another really long one. Luckily, I don't have to add those up. I simply look for the common ratios, or I look for the common difference, and then I look for the common ratio. 4 take away a negative 1, so 4 take away a negative 1 is 5. 9 take away 4, 9 take away 4 is also 5. And for completion's sake, 14 take away 9 is also 5. So I know I have a common difference of 5. So I'm going to use my arithmetic sequence. A1 plus n minus 1 times the difference. My first term is negative 1 plus n minus 1. My common difference is 5. Again, they want us to distribute and simplify. So I multiply the 5 all the way through. That gives me negative 1 plus 5n minus 5. That gives me 5n minus 6. So I have a summation of n equals, we always start with the first term. And how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 terms. 5n minus 6. Last one. 6 take away 2 is 4. 18 take away 6 is not 4. So it's not an arithmetic. We'll check to see if it's a geometric. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is also 3. So I know it's geometric. My common ratio is 3. A1 r n minus 1. My original term, my first term, is 2. My ratio is 3 n minus 1. So I have a summation from n equals 1 to 1, 2, 3, 4, 5 terms of 2, 3, n minus 1. Just that simple.